I'm here to give you a sneak peek of something I've been working on. I'll have this link in the description, and it's a framework I've been making for Flutter called Houston. It's actually kind of been an on and off again project for me, different methodologies, different principles, but ultimately it's meant to make a good developer experience. So I'm on the GitHub here, and I can just hit the period key, assuming I'm logged in, just to give a quick little look at the structure of it. You can do this on any GitHub repo if you didn't know. It basically just opens up a VS Code in web browser, and you can explore it the same way with most of the same shortcuts as VS Code. So we can look at it. There's an app folder, a CLI folder, and an internal folder. This will be the repo that is for the open source project. Likely there'll be another repo that is specifically kind of like to get started, where you wouldn't necessarily need the internal folders, and the CLI would probably just ship as a binary, but this is still very much a work in progress. To give you an idea of the structure of the Flutter side, it's all within the app folder. And we can go inside lib, and we'll see there's a main.dart, as you would expect, and there's a source folder. We have config, core, and feature. Now, feature is where generally most of the work would be done by the developer. This is when you're creating a specific feature, but there's nothing stopping you from, of course, editing certain core parts that you wanted to change, and obviously the configuration, editing things like your environment or your theme. Looking at one particular feature, we will look at the food feature. This is basically just something that shows a list of foods, and we have sort of like the model, which is basically just a freezed model. We have various components, things for cards and details and form actions in the form. We have various providers. We're using Riverpod in here, and we have a list provider, a detail provider, and a form provider. We have screens for each feature, so detail, edit, and list. And we also have some services. One's a DB service, which we'll look at in a bit, and then there's also one for a REST service. So pretty straightforward structure that based on the decision of this framework, this is kind of what you would do for pretty much any really model that you would need in your database, whether that's a to-do if you're making a to-do list, or a user profile if it is a social network. Let's take a look at how this sort of looks on the front end. Now, it's important to note that this is really a project meant to kind of scaffold and get you off the ground quicker without having to write a lot of the annoying sort of boilerplate stuff. But this is essentially what would be created in a particular feature, the food one I was looking at before. So we have the list, we have a detail view of it, which really, for this demo just shows the name again, nothing interesting, but it is its own component. We have an edit screen with an edit form. We can, of course, rename things, and we are able to also create new ones, and we'll get that in there, and we can, of course, delete. So your basic CRUD, create, read, update, and delete, which is basic, and I'm sure many of you watching have done this thing before. It's basically software development, making things interactive, and so on and so forth. Now I want to speak a bit about the backend. In my most recent version of Houston, previous to this one, the backend was sort of a Python Django based application, and that's all fine and good, and I love Django, but in building this I really want to create something that a Flutter developer without any other language experiences or dealing with DevOps and stuff can really go and get out and build. So what I've decided on kind of as the primary turnkey backend is Supabase, which is getting pretty popular on in the Flutter community. And Supabase is pretty cool. It's a Postgres database. It's much like Firebase, but it's open source. And instead of like a Mongo sort of database, it's a Postgres relational database, which I much prefer, especially in building applications. So that was kind of part of the decision. But I am building it in mind where, sort of like the database layer is kind of agnostic, and in theory you could swap it in with a different backend or RESTful service or whatever you wanted and still kind of reap the benefits. So I'm just going to give you a quick tour of Supabase in case you're not familiar. Basically, you have a table editor, and this is kind of like something like phpMyAdmin if you've used that before back in the day, but you can see all your data in here. It's, very much like a spreadsheet of data. And I'm actually going to delete this table because during this demo, I want to show kind of how it can all come together. So I'm just deleting this album table, but that food table that we were interacting with right there, you can kind of see the fields in here: banana, apple, bread. If I was to make another one, it would show up. And basically, it has an ID, it has a created at, a UUID, a name, a profile, which is actually a foreign key relationship. So it's just storing the ID, but at the database level, it actually has an index to be able to know that it's referencing a particular profile, which profiles here. So that's there's a lot more to Supabase. There's edge functions. There's a lot of the things that you'd see in something like Firebase, minus a few things. But I think it's a really great product, and it's actively being built, and it's open source. So although you can host it very easily with them, without having to know anything really about DevOps, you can also bring it and host it yourself if you just prefer to do it that way. Okay, so getting into this, I now have this open in VS Code. I'm just going to kind of give you a quick sort of rundown of how stuff goes in. So first of all, we have an environment. This is just a custom class called env, different flavors you can use, and essentially you have some different environment variables you can put in these env files. And if you've seen some of my other videos, you've probably seen this exact same pattern before. So that's how you can kind of configure like a staging environment, production environment, maybe a QA environment, et cetera, et cetera. We have a few different singletons. So we have a singleton for shared preferences. That's kind of for like, storing just like local settings to the user, and it works between web or iOS or Mac or whatever. We also have an app router. We're using AutoRoute, which is a really nice package that, again, you've probably seen me use before. And we're using basically the storage class that ultimately works with shared preferences to be able to just easily write keys and stuff. And then we have this thing called Supabase client, and this is how we interact with Supabase. Okay, so there's some singletons. Because we're using Riverpod, we have to wrap everything in provider scope, and then we have this lovely app. Now, something right off the bat I want to mention is the way I like to sort of handle my components, especially because I use Riverpod. I don't like to have to be like, oh, I got to wrap this in a consumer now. I got to wrap this in a consumer now. So there's this concept of base component. And base component ultimately extends consumer widget, which is Riverpod's widget, and basically has a build function, which also, aside from just having context like it normally does, it also has a widget ref. And this is how you can access your state and watch your state and stuff like that. And what's cool about this base component is not only does it wrap it in that, you don't have to like worry about always using these. It also has sort of these build functions that instead of working with the build, which you can, like this one is using the build, but you can actually supply instead body MD, and body large. That way you can kind of do responsive design right at the widget level, and it will essentially only render things based on if the screen size is a certain size. Ideally, you would start with body, and everything would wrap and end up using body until you've overrode the next one, or you overrode the next one. So it's a nice pattern, and I use it in pretty much all my applications. So we have the material app.router, which allows us to talk to our app routers config so that all the routing is kind of handled outside of this file in our actual router. And if we look at our router, which is just called app router, we will see things like the login and register and welcome and edit profile, but then everything's inside this thing called the dashboard router. And this is basically where right now, really the only route is sort of the profile routes and food routes, but we would add more as we add more features. And to look at the food routes, which actually get stored in a separate file, which is just part of this sort of feature-based design. If we open this up here, you'll see feature, food. There's actually a routes.dart for the food. We have sort of the list route, which just has no path, and then the food detail route, the create route, and edit route. Now, something else also that's important to me for this framework is full web compatibility, meaning we want to be able to have deep linking of URLs, and essentially the way everything works, we're never passing objects to a route. We're always just passing something that can be stored technically in a URL, which allows things like the web to, if you just came to that page on your own without actually coming from the previous page, like someone sent you a link, as long as we have the UUID in the URL, we can of course go and get it. And sort of that pattern is pretty straightforward, and we'll take a look at that in a little bit. So that's kind of routing. So let's look at a screen like the list screen, which you would come to, as sort of like the initial route in this tab right here. So the list screen itself, it's a route page, and that's just a decorator for auto router, so that it knows to put it in, make it a route, which all gets generated in the app generation for auto route. And this extends something called base screen, which is very much like base component. The difference is, so it's still doing consumer widget, but the build function itself is actually where the scaffold is done. And this just allows us not to actually create any scaffolds. Instead, what we're actually creating are functions like body, which ultimately gets pulled in from the body of the scaffold. You'll see if you walk through this, you would see ultimately a builder, and this is where the logic for, depending on screen size, you can actually kind of override body MD, body large, that kind of stuff. We can also create a floating action button on a screen just by overriding the floating action button, which by default, if we actually look here, it just, if I can find it, floating action button just returns null by default. But we can of course override it. And same with our app bar, and there's also like something for the bottom sheet and all that kind of stuff. So screens are pretty cool in that way that you're not really like having to make a scaffold. And if you wanted to change like the styling of your screen or change the padding of it or something, you could just basically do it in one spot. So that's this screen, and ultimately it goes to this component called food list, which this will be a base component. And what we do with RiverPod is we just go and talk to this list provider, which we'll look at. And it ultimately just returns this sort of abstract component called infinite list, where you actually pass in the type. And this does all the magic work. And this is a file you could, in theory, edit yourself to customize to your liking, but it's just a reusable component that deals with infinite scroll and all that kind of stuff. Now, the way the list provider works, if we look at it, we'll see food list provider. And I'll get into why there's kind of like this annotation here and why it's extending something else in a bit. But ultimately, the food list provider has a paging controller, and that works with this package called, what is the package called? Infinite Scroll Pagination. And it's just a really nice way to deal with pagination and fetching pages. And basically what we do when a page request comes, which happens on load or when you scroll to the bottom, or if there's still room, in this case, I only have a few things, so it would have potentially tried to call the next one because I'm technically scrolled to the bottom. But we basically go and we try and list it, and what we do is if we can load more, we append the page. Otherwise, we append last page, which this is just part of that package, and it knows like, okay, I'm going to get rid of this listener and stop trying to request pages. And because all this data is ultimately attached to the paging controller, that paging controller in our food list is used here on this to do this, and we build each item in the list like this. So the food card, for instance, is a very basic card. It's really just an inkwell with a card in it and some padding and the name of the food. So that's kind of how this screen works. Now, how do we actually get that data? Well, if we went back to the provider and actually clicked through a couple things and went to this list function, so this is using the DB service. And ultimately, this is going off, and it's calling this thing called list data, which is kind of like a shared function that's built into this thing called DB service. And in here, we actually use the Supabase client to get something from whatever table we've passed in. And the table is actually something that is set right here. You'll see table. We're overriding kind of like what the table name is. Because in theory, on each particular service, the food DB service, you'd be using the food table. So we only need to set it in one spot instead of everywhere. So if we go here, we'll see it actually gets from the table and it selects, and it uses this thing, the select statement that you could pass in, or its default select, which is actually just star by default, but you could override it, and this is helpful for doing like foreign keys and stuff like that to get joins and all those kinds of things. So we select it, and then it returns stuff, and we actually have some stuff in here for dealing with pagination, because we don't want to be like, give me all of them, especially if there was like a million rows. We just want essentially the first, this is like a range offset thing. So a little bit of math going on here, whatever the page is, -1 times the limit, and then the end of it would be the limit times whatever page you're on. So that would start with like 0, 10, and then 11, 20, so on and so forth. All right, and that's kind of, a nutshell of how that, the actual list part of this works. Now, the detail part is even simpler. If we actually go to a screen, let's go to a food detail screen. So like we saw in the route, a UUID needs to be passed in. We're not actually ever passing in the food item itself, and that's just to support, web and deep linking and not, just have things kind of live and have their own ownership of the data. So we have an app bar, which we'll just kind of ignore, but let's look at the body here. So what we actually do is we're watching this food detail provider, and this is a future provider. It's actually specifically a family feature provider, meaning we can pass in something unique like a UUID. That way it caches it, and unless you purposely go, hey, invalidate this and give me it again, it'll just stay in memory and you're not making network calls as much. But basically we have this, and we just have to call the function, which is the retrieve function on that DB service, which we didn't really look at, but it's similar to the list, just a little bit simpler because it's only returning 1. And something that's probably worth noting is because we are using freezed, we get all the lovely built-in stuff like from JSON and to JSON and all that kind of stuff just by sort of decorating our model. So putting things like the name, string name, or a reference to another thing like a profile or created at, etc., etc. So this goes and retrieves it, and technically it's returning a future because this is actually an async function. And over here we have the model, and we say we can actually run, this is just part of RiverPod, we can go through these few different options. So sometimes the model might be loading, and when we're loading, we just want to show a circular progress indicator. There might be an error. Okay, we're just going to show, the word error in this random component that's just called empty placeholder. That's just a nice, helpful thing. But if we get the food and it's not null, we actually go and send back the food, return back the food details. If it is null, there's also an error, so we're kind of doing the same, sort of repeated thing here. And then, so I like the screen really to be like, it's just to do with the screen. It's the app bar, it's the content, the body, and then we go into here. And from here, we're passing in the food because this food details will never exist on its own. It's not a screen. It's going to be wrapped in this screen that will either get it or it won't. And from here, we just have this, pretty boring screen, but basically we're just returning a column with this. But we could, of course, in here put something like food. I'm not even sure what else food has, to be honest. Food dot, but yeah, we could put the UUID, sure, just to show people, and we would see that coming in there. So that's kind of how detail works, and it's nice because, yeah, if we were to build this to web, you could just come right to, whatever the route was for this, which is something like /food/UUID, and it would do all the rest for us. Okay, now I'd say the last piece of the puzzle is the way our providers sort of work. So we've looked at the detail provider, we looked at the list provider, we haven't looked at the form provider yet. I'm going to open it up, but first let's just start with the screen so we can kind of walk through it. So we have an edit screen, and all the edit screen does is, again, passes in the UUID of that. So even the edit screen is something you could come to from a permalink. And the food form, so this is the screen, and it basically gives back this component called food form, which is a place we can put all of our fields. And for food, because things like ID and UUID is already, kind of like read-only, it's controlled by the backend. We don't need ways to edit it, so it's really just one field. But obviously there's more going on here. We have, if you look here, we have this save and delete button and cancel button. We have back, we have a whole bunch of stuff. And that's because the food edit screen also has a bottom navigation bar for the food form actions. And we also have the app bar for the edit food. But let's take a look at the form. So here we have the form, which really just is returning this, but there's more to it than this, and we are extending this thing. And again, this sort of like annotation might be confusing right now, but it'll make sense later on in the next part of this video. But if we go here, there's actually a lot more going on with our food form. However, we really only care from the developer's point of view. Generally, we would only care about, maybe reordering the fields or making it a different decoration, or making this, maybe we want to have different lines, like, 30 lines or something, That's the kind of stuff we really care about from a developer point of view of what we might want to edit. Whereas there's sort of this boilerplate stuff, like, yeah, we're going to wrap it in a single child scroll view, and that's because if the form is too long, we want it to be able to scroll, which I don't know if I can even get it small enough. Yeah, I can. Look at that. So it's still scrollable, which is helpful. And ultimately, all it does, it also wraps in a form and talks to this form provider that we will look at as well, to get the form key. And then ultimately all it does is makes this column where it puts the children of the fields. And fields by default is just an empty array, but we are overriding fields here, and thus kind of making our own implementation of it. Cool, so let's look at the form provider. So our food form provider, if we look at it, is also a family, which allows us to sort of have that UUID referencing it. So if we're editing one, form item, it's everything we've done is kind of isolated from a one with a different UUID. But basically what this allows us to do is we can add different field listeners. So we'd want to have one for all of our controllers, our name controller. We also have validators for all of our fields, or the ones that we would need validation. So this one, for instance, form validator not empty. These are just some helper methods you can easily find in the source code to, instead of having to type out basically this whole thing, it's just a reusable sort of thing. And we have different form validators too for like validating passwords and validating usernames and phone numbers and emails and so on and so forth. But we want to be able to listen to those changes of those things so we can update the state, because the way our form provider works is if we actually look at the full version of it, the generated version of it, again, will make more sense later. We will see that it is ultimately food is the thing being referenced here, and we can update our state anytime so that the form model can change, and we can do stuff. So within here, where there's already a function to load it based on if the UUID is empty or not. If it's not empty, we go and retrieve it and make sure it's still not null, because it could potentially return a 404. Otherwise, we do this thing called handle empty, and all this really does is return, an empty version of food, which is just sort of this helper method factory on food, just to kind of return one that still fits this without breaking anything. We also have functions for discarding. When we clear something, we want to handle the empty, meaning come back and give this an empty guy, as well as clear the fields. We have a delete function, and we have a submit function, and the submit actually validates the form as you'd expect. We start this loading process. We then try to save it by going to our DB service, and the save function basically checks if it already does exist, meaning the ID is not 0. It will just try and do an update. If not, it will try and do an insert and then return back the object. Yeah, so, and then there's these empty ones here, and this is the stuff you would override, right? This is the stuff generally as a developer, you would want to change. Maybe I want to clear things differently. Maybe I want to, an empty one. For instance, we have to override empty here because food actually has a reference to a profile, which is the user's profile. And we want to make sure that when a new one is made, that it's an empty one where we're copying the profile over, so that right from the point of working on it in the form, and when we save, it actually has a reference to that profile. Okay, so I think that's kind of like a decent walkthrough of stuff. I'll show you one other pretty fun UI thing, the way the dashboard works. Essentially what we do is we have a list of these routes, and we have these bottom navigation. I realize I'm going to delete this one. This was just from testing something earlier. And we have these we have a top nav, but we also have tabs. And that's because the way our dashboard container actually works is it's using kind of that whole concept of like a base component, and it actually renders differently. There's a body version of it and there's a body MD. And the reason that this is true is because we kind of want, like, on a desktop experience to maybe have the nav up here, but on a smaller experience, which because I just made that change, but probably didn't actually update something. Let's see. That's probably the case. Let's see. One second, and we're going to figure out, there's something where the length is wrong. Food route, bottom route. Okay, it was actually a silly thing. Technically tabs, like a bottom navigation bar, has to have at least 2 items. So I just kind of copied this one temporarily so that you can kind of see the difference. So you get the tab bar down here versus when you get big enough, you sort of get this, this other thing. So it's just a nice layout sort of shift. Okay, so now the real purpose of this video is kind of showing, cool design pattern, awesome. Maybe I'll follow that, maybe I won't. But the real value of Houston is really this like code generation and scaffolding. So let's just take a quick look at some things here. So I'm just going to go back to my terminal and sort of clear some things out, and we'll close these guys because we don't really need them. So we have this thing. We've only really looked at the app. We also have this internal, which I'm not going to get into on here, but this is where there's sort of like a lot of like generators and stuff like that. But we also have the CLI. So I'm going to go into the CLI directory. And just as a reminder, because I forget the command, yeah, it's really just this here. So when I'm in the CLI directory, I can run dart bin/cli.dart. And we get this little prompt here. This is very much an early version of the CLI. I'm sure there'll be a lot more functionality, but we can type help and kind of see the things. Right now, we have the option to make a new feature or scaffold a feature, as well as exit and see the help menu. So I'm going to do something. I'm just going to, I still have this blueprint here. I'm going to just copy it all to my clipboard and delete this file just so we can kind of see it from scratch. So I'm going to do new. And we're going to call it album. And it's basically generated this YAML file here called album, which is just kind of like has the name of it and then this empty placeholder properties. I'm going to paste back in what I did and kind of walk you through. So this is where we can kind of design the model itself. Things like, okay, it's going to have a title, a description, a year. It's going to have a profile, which is a reference to another model. So the type is actually profile. And there's going to be a created at for date time. And we can, of course, make more fields. You might have an artist, maybe a reference to another model called artist, or just an artist name, et cetera, et cetera. And what we're going to do is, so we have this file, and blueprints are kind of like, this sort of like blueprint of your model. To look at the food one, it's even simpler. It's just a name, a profile, and a created at. You'll notice there's no ID or UUID in there. Those will always be created. I also have one for track, sure, which seems like it would go well with album, but we'll see if we can get to that. So now the next thing is we're going to type the word scaffold in our CLI, and we are going to type in the name album. So kind of a 2-step process. First you kind of like set up the structure of it, and then you actually run the scaffolding. And we're good. We can get out of the CLI now. We'll go back to app. We'll see it's red, and that's because stuff is actually generating still. So there's files that should exist that don't exist yet, so on and so forth. But let's see. We have this new folder called album, which is pretty cool. And it's almost there, and we're good. Everything's green again. If we go to our problems, we won't see any. I do have some warnings and stuff. I just have those filtered out because right now I don't care about them. And we can see a very similar structure to what we had before. But the biggest difference is it's basing it off of this, right? So if I go into the album.dart for the model, we see we have the ID and UUID, which I said would get auto-made, but we have the title, the description, the year. We have a profile. We have created at, this is part of created at. And actually, it runs the Dart formatting as well when it does it. The thing is, there's the settings in my VS Code are actually slightly different than the default one, so I still sometimes like to resave just to get it the way I like, which is like a longer. I don't need it to be that short, but that's just a small side note. Yeah, so it generated this model, and what's kind of cool is we have this, like, in this case, a double level of generation, right? We have sort of like the code scaffolding, which to me is like code that you're just getting started with. It's like, it's meant to be editable. It's still like, okay, I want to add it. I don't want to have to regenerate everything and lose my work. I'm just going to add one new field, cool. Or I'm going to make a new factory that's something helpful for me, or some helper methods or whatever. So these files are, whereas, the files in freeze, if you actually like look at this, you can't really edit this file. It'll get wiped out. But this has all that like boilerplate for like copy with and, all that stuff to JSON, from JSON, all those exciting things. So yeah, we can work in this file, we can make a change, we just have to regenerate and it will, update this, and that's nothing to do with Houston, that's just a freezed thing. So yeah, making a model, that's fine, but really making this one file, sure, it's a little bit more code than this, but it's not, it wouldn't be, that crazy, but we are generating everything. We have all the components. We have the album card, which again, is basic stuff, but this really adds up, making all these files, right? And, all the naming's really nice, and, is using that, based on the name. We have our form. Now, here's where I'll kind of show this, like, there's kind of like, I guess, almost 3 layers of generation in Houston. You have the scaffolding stuff that I've said. Then you have sort of the second layer of generation that is still internal to Houston, which is where we can annotate things. So there's different annotations like Houston form. There's annotations for a few of our providers, and they actually create these generated functions, Houston album form. So again, we wouldn't really edit this because yeah, if you decided to make a change here and then reran the generator, your changes would get wiped. It is very much based on this, how it's set. But if I did want to make a change, the process is you override things. So I could just override the body function and do it. I could start by just copying and pasting it if I wanted, and then making my changes. But I'm just trying to make it so that for the most use cases, you only have to really work in these files with the most minor parts. No boilerplate necessary. It's kind of hidden from you in the background unless you really want to dig in. So yeah, what kind of happened here? It auto-generated the text form fields for me, the description controller, the year controller, that kind of stuff. Yeah, a lot more you could look into. Now, something else that got generated that we need to do before we can actually test this is it generated some SQL for us. So we can actually go and copy this, and we can go over to our lovely Supabase and go to the database or the SQL editor tab, and let's just paste in that stuff and click run. It's going to warn us, hey, is this safe? Obviously, like, don't take my word for it. But it's pretty basic. It's just creating a table, and in fact, it's only creating if it doesn't exist. So if you ran it a second time, you wouldn't really ruin anything. But yeah, there's there's the table made now. And we can confirm that it worked by just going here and seeing, yep, okay, there's our album table, no data in it yet, but it has sort of the fields that we set up, the description, year, these auto-created ones that Houston does for you, and it even has this reference to the profile, and it is actually a foreign key. A lot of magic going on there. So let's actually take a look at this. Now we will have to, because of all this generation, we will have to glue a green arrow restart, but we don't even have to like rebuild it from scratch because we didn't install any native plugins. And we'll actually see, oh, this is here. And something I am actually pretty proud of is not only is it generating this folder, it is making some minor changes just to really like get you off the ground. If we actually go to our, for instance, our routes file, or sorry, the app router file, it actually added this in here as well as the import for it. And that's just, yeah, some exciting magic to do. And that's why there's sort of these few little tokens spread out to know like, okay, this is where the route's supposed to be inserted so that the generator can do it. If you were to remove this, it wouldn't break things, but you'd have to manually come and do it. And it also did something similar in the dashboard where it created this, new route here, the import for it. It created this. I'm just going to erase the temporary one I made. And so on and so forth. And it yeah, just kind of worked. But yeah, if we go back here now and we look at album, we'll see, okay, there's nothing here. But we can make a, cool album. Awesome. We'll use today's year and we'll click save and we have it there. And we can of course we can go and edit it, change it to this. We can delete it. We can, do all that. It's basic, but in software development, like this is kind of like a lot of the time, a big chunk of your work, right? Just like getting this all working and, finding errors and stuff. So I'm not saying this is completely bug free. Like currently, this is a very early preview of what I'm doing, but it's because it's using code generation stuff. If there is a bug that's found, we can fix it in one spot, and then all, everything else that we generate moving forward would, be fixed. So yeah, there you have it. Yeah, still a bunch more to, to do on this project. It's by no means done. It'll be a work in progress. But I think it's at a place, and in fact, not this particular version that you would see, but I've used this on quite a few production apps, sort of like a previous version, again, tied to my Django application, as opposed to this version that uses Supabase. But it is definitely, stable and works in production and also in web. Yeah, I hope you enjoy it and learned a few things, and I'm excited to hear what you think. All right, have a great day.